Good morning, vibrant city of Valenzuela. I am Oliver G. Mariano from Citera Francisco Memorial National High School. Join me in another learning experience here in Valenzuela Live, your live streaming school. We are now on the fourth quarter, weeks 8 and 9, which is about analyzing and interpreting research data. For this session, you are expected to meet this most essential learning competency, which is to use measures of position and other statistical methods to analyze and interpret research data. So to begin, let us have our first activity entitled Picture Picture. You need to use the pictures that I will be flashing to unlock the statistical term hidden behind these pictures. Are you ready with our first one? Great! So here is the first set of pictures. You have 10 seconds to guess or unlock the statistical term, and that starts now. Time is up. What do you see on the picture? Nice. We have the pause button, a C, and Sean Mendez. Now, the correct answer or the correct statistical term behind these pictures is position. Let us go to the second one. We have the following pictures. Your 10 seconds begins now. Time is up. What do you see on the picture? All right, you have a per, a cent, and an aisle. Taking them all together, we have percentile. Did you get it correctly? All right, let's move to the next one. Here is the third set of pictures. Your 10 seconds starts now. Time's up. The correct term behind these pictures is range. So as you can see on the picture, you have rain and the letter J, which sounds J. Let's have the next one. As a clue, the statistical term behind these pictures contains two words. You have 10 seconds. Go. All right, that's it. We have standard deviation. Let's have the last one. Your 10 seconds starts now. All right, time's up. What pictures do you see on your screen? You're right, that's me and John Legend. So we have me, John. All right, I guess you were able to at least recall some of the statistical terms that you have learned starting from your grade 7 and up to now. For this lesson, we will be dealing more about how we analyze and interpret research data which are obtained from the computation or calculation of such statistical measures. So to formally recall all the terms that you have learned so far, we have the measures of position. And I know that you can clearly recall all of these terms up to now. We have quartiles, deciles, and percentiles. Another set of descriptive measures in statistics are called measures of central tendency. We have the mean, median, and the mode. Last one, we have the measures of variability, which are range, variance, and standard deviation. Let's explore each of these as we use them in analyzing and interpreting research data. So let's focus first on measures of position. Consider this situation wherein a restaurant was able to obtain a data set for the favorite dishes of its customers. The results are as follows. We have 9 customers saying that their favorite dish is pork adobo. 8 of them for pancit, 5 for pork chopsteak, 7 for grilled diempo, 4 for sinigang na maya-maya, 6 for fresh lumpia, 5 for bulalo, and 7 for fried chicken. Now, the restaurant owner wishes to answer the following questions. Since the restaurant is having difficulty in preparing fresh lumpia, should they phase it out? And if the top 25% dishes are considered best sellers, what are the best seller dishes in this restaurant? To address these questions, we need to make use of measures of position. Let us concentrate on the first question. Since the restaurant is having difficulty in preparing fresh lumpia, should they phase it out? To answer this, we need to find the percentile rank of fresh lumpia and see whether it is somewhere that is below the first quartile. The first thing to do is to arrange. And in order, in ascending order, we have 4, 5, 5, 6, 7, 7, 8, and 9. Again, this refers to the number of customers who are having their favorite dish as presented in the previous table. Here, we can say that the fourth item or value in this ordered or ranked data set refers to fresh lumpia. And let's assume that its percentile rank corresponds to X. Clearly, we have 8 as the total number of observations, and the position of X is 4. To solve for the value of K in this equation, we have the position of X is equal to K times quantity n plus 1 all over 100. Substituting, the position of X is 4, n is 8. So we have 4 is equal to K times quantity 8 plus 1 over 100. Multiplying both sides by 100, that gives us 400 is equal to 9 times K. 9 because 8 plus 1 is equal to 9. And dividing both sides of this equation by 9, that gives us approximately 44.44. This now refers to the percentile rank of fresh lumpia. As we all know, if your percentile rank is approximately 44, it is located between the first quartile value and the second quartile value. So therefore, fresh lumpia should not be phased out because there are 6 of them, 6 of the customers, who might be lost from the restaurant just in case that the owner decides to phase out fresh lumpia. Let's consider the second question. If the top 25% dishes are considered bestsellers, what are the bestseller dishes in the restaurant? Again, the ordered values in the distribution are 4, 5, 5, 6, 7, 7, 8, and 9. Top 25% means that there is a point in the distribution which divides it into the lower 75% and the upper 25%. That means that we need to find the value of P75 and see how many values in the distribution would fall above P75. To do that, let us locate first the 75th percentile. By the locator formula, L is equal to K times quantity n plus 1 over 100. And by substitution, it would yield 75 times quantity 8 plus 1 all over 100. But 8 plus 1 is 9. So we have 75 times 9 all over 100. Multiplying all the operations, we get 6.75. 6.75 lies between 6 and 7. As we can see here, the 6th and the 7th value are 7 and 8. And so P75 lies somewhere between 7 and 8. Using linear interpolation, you may find and you may verify on your own that the value of the 75th percentile is 7.75. Now, as you can see, we colored the last two values as orange. What does that mean? It means that these two values are greater than P75. So therefore, they belong to the top 25%. Now, which dishes corresponds to these two values? If you will recall from the previous table, we can say that pancit and pork adobo are the best sellers in the restaurant. Do you have questions? Feel free to plug them in the comment box. Let's now proceed to another example. Let's consider the situation wherein we are given the scores of 50 test takers in an entrance exam. So we have here the following ranges of scores. For 30 to 39, the frequency is 3. For 40 to 49, we have 9. For 50 to 59, we have 8. For 60 to 69, we have 10. For 70 to 79, we have 8. And for 80 to 89, we have 12. You may also recall that the cumulative frequency are obtained by adding successively the frequencies starting from the last row. So we obtained there 3, 12, 20, 30, 38, and 50. Now, the college who conducted this entrance exam would like to examine the following questions. First, the college decides to admit half of the test takers. What must be the cutoff score? Another is a scholarship will be given to the top 10% of the examinees. What is the least score that qualifies for the scholarship? Again, just like with our first example, to address these questions, we need to make use of measures of position. For the first question, we need to find P50 or the 50th percentile. Why P50? It's because since we are taking the half, it means that the entire distribution is divided into two equal parts, which clearly represents the median. And we know for a fact that the median is the same as the 50th percentile and is actually the same as the second quartile and the fifth decile. But for this illustration, instead of Q sub 2 and D sub 5, we will be using P sub 50. Again, we were given earlier this frequency distribution table. The first thing to do to find P50 is to compute for the locator formula or location of P50 using the locator formula. That is K times N over 100, which is equal to 50 times 50 all over 100, and that gives us 25. Now, looking at the cumulative frequency, the nearest value to 25 that's greater than 25 is 30. And that is on the class 60 to 69. Meaning to say, the class 60 to 69 contains the 50th percentile. From this, we can also identify that the lower boundary is 59.5, the frequency is 10. The less than cumulative frequency before this class is 20, and class size is 10. Using all this information, we may now compute for the 50th percentile. Substituting all of those in the formula that you learned in the previous lessons, we have the 50th percentile is equal to 59.5 plus quantity 25 minus 20 all over 10 times 10. Performing the operations, that yields 59.5 plus 5, which is equal to 64.5. Since the scores are all whole numbers, therefore, the cut-off score must be 65. All right. Let's move to the second question, which is a scholarship will be given to the top 10% examinees. What's the least score to qualify for the scholarship? Again, with reference to this frequency distribution table, we shall find now for P sub 90. Why P sub 90? Again, if you have top 10%, that means that the distribution is divided into the lower 90% and the upper 10%. And that corresponds to the 90th percentile. So, to start solving for P sub 90, we again use the locator formula, which is K times N over 100. Substituting, we have 90 times 50 all over 100, and that gives us 45. Looking at the cumulative frequency column, the nearest value to 45 that's greater than 45 is 50. And that is under the class 80 to 89. Meaning to say, the class 80 to 89 contains the 90th percentile. From this, we can also identify that the lower boundary is 79.5, frequency is 12, the less than cumulative frequency before this class is 38, and the class size is 10. Using all this information, we can now find the value of the 90th percentile. So the 90th percentile is 79.5 plus quantity 45 minus 38 all over 12 times 10. 45 minus 38 is 7 times 10, that is 70. So we have 70 over 12. 79.5 plus 70 over 12 gives us approximately 85.33. And again, because all the scores in the exam are whole numbers, that only means that we round this up. And so the least score that would qualify for the scholarship is 86. Again, should you have questions, feel free to drop them in our comment box. At this point, I guess you are now ready to head on with our second activity entitled Say Yes, Say Yes. I will be posting a question and you need to determine whether that question can be answered using measures of position. If you say yes to that, just drop the thumbs up emoji in our comment box. But if you're saying no to that, drop the thumbs down emoji. I will give you 5 seconds to think about each of these items. Are you ready for the first one? All right, so here it is. Number one, how well did John perform in his math quizzes? Your 5 seconds starts now. Time's up. We are saying no to this question. It cannot be answered using measures of position. Let's take the second question. What percent of John's classmates have grades lower than his grades in mathematics? I'm giving you 5 seconds and that starts now. All right, that's it. This question may be answered using measures of position. It's a yes. Let's move to the third one. Is Miss Gatchalian's class homogeneous or heterogeneous in terms of intelligence? 5 seconds, go. That's it. This question cannot be answered using measures of position. What about this last question? What is the maximum family monthly income that may be considered for financial assistance? You have 5 seconds, go. All right. The correct answer is yes. This may be answered using measures of position. Are these concepts now clear to you, grade 10? Very good. Let's continue our discussion by looking at other statistical methods that we can use in analyzing and interpreting research data. Let's begin with what you learned as early as grade 7, the measures of central tendency. First is a measure of central tendency, which is also referred to as measures of center or central location, is a summary measure that attempts to describe a whole set of data with a single value that represents the middle or center of its distribution. The most common one is the mean, which is denoted by X bar. The mean is the sum of the values of each observation in a data set divided by the number of observations. This is also known as the arithmetic average. Another measure of central tendency is the median, which is denoted by X curl. The median is the middle value in a distribution when the values are arranged in either ascending or descending order. And we also have the mode, which is denoted by X hat. This refers to the value that occurs most often in the data. To see how these are used in analyzing and interpreting data, let us consider this situation. Records show that the average time for a high school athlete to complete a 400-meter sprint is 65 seconds. A coach listed the running time in nearest second of his 10 athletes as follows: 58, 62, 62, 68, 65, 56, 59, 69, 61, and 67. Analyze the average running time of the 10 athletes using the measures of central tendency. It would be easier for us to work on this situation when we arrange these values. Doing so, we have 56, 58, 59, 61, 62, 62, 65, 67, 68, and 69. To start, let us solve for the mean. The mean again is obtained by adding all the values divided by the number of observations. Since we have 10 values here, we add 56, 58, 59, 61, 62, 63, 65, 67, 68, and 69 and divide the result by 10. That gives us the mean value of 62.7. 62.7 seconds is definitely reflects a speed that is faster than 65 seconds in terms of running. Therefore, the athletes have above average running time when we look at the mean. Let's see whether the same thing yields when we look for the median. For the median, we solve or we try to look for the middlemost value. Since there are 10 observations, the middlemost value is located between the 5th and the 6th value. And these are both 62. Taking the average, still we have 62 for the median. And 62 still is a time that represents something that is faster than 65 seconds. Thus, this yields the same interpretation as when we consider the mean earlier. Last, let's verify for the mode. The mode may be obtained by merely inspecting the given set of data. As we can see, the most occurring value is 62. So our mode is 62. And in the same manner as previously stated, we can say that the athletes have above average running time. So as you can see, the measures of central tendency for this particular example yields the same analysis and interpretation of this result. Let's now look at another set of descriptive measures called the measures of variability. A measure of variability, also referred to as measures of dispersion or variation, is a summary measure that attempts to describe how a distribution is scattered or spread. We have the following most commonly used measures of variability. First is the range. The range is the simplest measure of variability. It's the difference between the largest value and the smallest value. We also have the variance. The variance is the average of the square deviation from the mean. For this particular discussion, we will only concentrate on sample variance. And so the sample variance may be computed using this alternative formula. The other original formula for variance, which you learned when you were in grade 7 or in grade 8, will not be used for this discussion. So again, we have this formula, this alternative formula, s squared is equal to n times the summation of x squared minus the square of the summation of x, all over the product of n and n minus 1. Wherein s squared refers to the variance, n refers to the number of observations, and x refers to the data value. We also have standard deviation. Standard deviation is said to be the most reliable measure of variability. It tells how far the values in the data set are away from the mean. Obviously, when you try to connect the formula of this one to the formula of variance, you can clearly notice that the standard deviation is just the square root of variance. So S is equal to the square root of n times the summation of x squared minus the square of the summation of x, all over n times quantity n minus 1. Still, S here refers to standard deviation, n is the number of observations, and x is the data value. To give you a clearer picture about how measures of variability may be utilized in analyzing and interpreting research data, let's consider this example. A researcher wishes to know which between the two hair treatments produces more consistent results among patients' hair growth. The average hair growth measured in millimeters for 6 months were recorded as follows. Those who underwent treatment A had 2, 7, 7, 9, and 5, while those who underwent treatment B had 6, 8, 5, 5, and 4. Let us look at how treatment A and treatment B compare in terms of their range. The highest and the lowest values in treatment A are 9 and 2 respectively, while that for treatment B, we have 8 and 4 respectively. Since the range is simply the difference between the highest and the lowest values, therefore, for treatment A, we have 9 minus 2 is equal to 7 as the range. And for treatment B, we have 8 minus 4 is equal to 4 as our range. Next, let's look at the variance and standard deviation of each of the data sets. For the variance of treatment A, we may come up with this table showing the given values in our distribution and their corresponding squares. So we have 2, 7, 7, 9, and 5, whose squares are 4, 49, 49, 81, 20, and 25 respectively. The sum of all the x values is 30, while the sum of all the x squared values is 208. Using this, we can now solve for the variance using this formula. Substitution yields 5 times 208 minus the square of 30 all over 5 times quantity 5 minus 1. Performing all the operations therein gives us 7. So the variance for the data given in treatment A is 7. Now, we learned earlier that the standard deviation is just the square root of variance. So for treatment A, the standard deviation is the square root of 7, which is approximately 2.64. Let us now compare that to the variance and standard deviation of the values given in treatment B. So for treatment B, we will be doing the same thing like what we did earlier for treatment A. So we come up with a table showing the x values and their corresponding squares. So we have 6, 8, 5, 5, and 4, whose squares are 36, 64, 25, 25, and 16 respectively. The sum of all x values is 28, while the sum of all the x squared values is 166. Using this, we can now compute for the variance for treatment. Using the same formula, s squared is equal to n times the summation of x squared minus the square of summation of x all over n times quantity n minus 1. We have 5 times 166 minus the square of 28 all over 5 times quantity 5 minus 1. Performing the operations therein, you get 2.3 as the variance of the values given in treatment. Now, for the standard deviation of the same set, again, the standard deviation is just the square root of the variance. So taking the square root of 2.3, we have approximately 1.50. To sum up all the measures of variability that we have just computed for each data set, we have this table. The range for treatment A is 7, while that for treatment B is 4. The variance for treatment A is also 7, while 2.3 for that of treatment. And the standard deviation for treatment A is 2.45, while that of treatment B is 1.50. What do you notice on the values that we obtained? Great. All the values for treatment B are less than the corresponding values for treatment A. Meaning to say, the treatment B produces more consistent results. For measures of variability, we have to take note that the smaller the values that you get, the more homogeneous the distribution is. Meaning the scores are very near from each other. While the larger the value that you get only means that the distribution is more heterogeneous. Let's now summarize what we have learned for this episode. First, the measures of position may be used to analyze and interpret data towards answering questions pertaining to ranks or location of a value in a distribution. And of course, other statistical measures like the measures of central tendency and variability may be used to describe a distribution. Since this is the last episode of Mathematics 10 Valenzuela Live, your home delight is just to write a journal entry that contains your greatest takeaway in your math class for this year. I'm hoping that you really had a great time watching from the very first episode of Valenzuela Live up to the last one. Again, this is your first and last Valenzuela Live math teacher, Oliver G. Mariano. Thank you and stay safe.